Hello everyone. This lesson is going to cover a topic called common factoring, which is something we do with many different things in mathematics, but usually with quadratics. Common factoring and factoring in general is actually one of the most important lessons in all of mathematics past grade 10. The ability to factor basically means to take something that's adding and subtracting and turn it into something that's multiplying. Adding and subtracting is actually one of the most difficult math concepts to work with in big expressions. So if you can actually write something as a multiplication instead, it usually makes everything a lot easier. Factoring is also the reverse of expanding. So I'm going to use these two examples here to show you how this works. All right. So if you have a 3 in front of a bracket and you're asked to expand, that means multiply the 3 into the bracket. All right. When you multiply the 3 into the bracket, you end up with, and I'm going to write this out a slightly different way. You get 3 times x squared. I'm going to write it out the long way, and you also get 3 times 2. And then most people will actually just go directly to the final answer, because 3 times 2 is easy to do, it's just 6. Now you can see that this final expression is actually the starting expression for this side. When I'm asking you to factor, I'm asking you to go back up these steps to finish with this final answer that actually has the bracket in it. So factoring is the reverse of expanding. But that means you need to be able to look at the two terms and see that 3 that I highlighted in green here hiding in both of those terms. And that's actually the most difficult part of factoring, is figuring out what is hiding in both of them that you can take out in front of the bracket. Now we can clearly see it's going to be the 3, but I'm just going to write this out. Here's what you'd have to do in your head. You can write it down as well. You'd have 3 times 1 that represents 3. Now what are the things that multiply to 6? You have 6 times 1, and you have 3 times 2. Now what we're looking for is something called the GCF, which stands for greatest common factor. Common means it has to be in both of them, the terms, the 3x squared and the 6. So what's the greatest common factor or thing that multiplies in all of these green numbers up here? Well, the only one that's common to both is the 3. There's a 1 that's common to both, but it's not the greatest common factor. The 3 is the greatest common factor. So that greatest common factor gets pulled out in front of a bracket. Now what's left over? You didn't circle the 1, so there's a 1, and there's also the x squared that we didn't touch. So there's a 1x squared left over inside the bracket. And what's left over from this term? Well, we didn't circle the 2, which is connected to the 3 that was the common factor, so there's a 2 left over here as well. And then you figure out what sign is left into the bracket. Now, for right now, it's going to be a plus, but that's going to change eventually, because if you have a minus sign as your first number in the expression, something interesting is going to happen, and I'll talk about that a little later. Now, I want to point out that we didn't use the 6 times 1 at all. So that one gets crossed off because it didn't contain the greatest common factor. Now, I want you to look at this expression, the 3x squared plus 6, and our final answer. Can you easily see that all we're doing is dividing out the biggest number that we can from both 3 and 6, putting that out in front of the bracket, and then putting the leftovers inside from that division? So another way that you can look at this is 3 divided by 3 is 1. 6 divided by 3 is 2. So let's look at another example. window here. Okay. So here's my expand, and here's my factor. So when I expand this, I'm going to do it the faster way this time. We get negative 4 times 3, which is negative 12x squared. And then negative 4 times 2x, negative 8x. And then negative 4 times negative 3 is positive 12, which is exactly the expression we have on this side. So if you can train yourself to look at these three numbers, and you're eventually going to have to look at the letters as well. Now, these two terms have a common letter. There's an x squared and an x. That means both of them share at least one x. But this doesn't have an x in it. The 12 doesn't have an x in it. So you can't have a common letter if it's not common to all three of them. But we do have a common number in all three. If I write out the things that multiply to 12, we'd have 12 times 1, 2 times 6, and then we'd have 4 times 3. Now the 12 is negative, so that means either the 4 or the 3 has to be negative, but I'll come back to that in a second. I'm just looking at the 12 right now. If we look at the 8, we also have 1 times 8 and 4 times 2. If we look at the 12 again, well, we already talked about all the things that multiply to 12, so we already know that 4 times 3 is going to be the 1. Now, why is 4 times 3 going to be the 1? Because all of them contain a 4, and the 4 is the greatest common factor. Now, we also have a negative 12. That means that I have to take out a negative number. Because the negative 12 is our first coefficient, we always want to take out the negative as well as the number. So that makes things a little bit more complicated. So if I want to take out a negative 4, well, that means that my 3 is going to be positive. If I want to take out a negative 4 from the 8, well, this is a little bit more complicated because I have to just make sure that these two multiply to a negative number, right? Well, that means there's going to be a plus 2 behind. Okay, and you'll see why that's a little bit more complicated in a second. For the negative 4 here, we're going to have a 3. Is it going to be a positive 3 or a negative 3 left over? It's a positive 12. Negative 4 times what is positive 12? Negative 4 times negative 3 is positive 12. So now, if I write that negative 4 out in front, actually let me do something here. I'm going to follow the same pattern that I followed above. So if I take the negative 4 out in front, what is going to be my leftover? My leftover is going to be a 3 and the x squared, because I didn't touch the x squared. My leftover here is going to be a plus 2 and an x. So why is the sign a plus 2? Because it was negative 4 times positive 2 that gave negative 8. So that switches the signs here. And the whole reason that the sign is switching is because we pulled out a negative number in front. Here's a minus 4 that's being taken out. What's the leftover is going to be negative 3, and you'll see that the sign has also changed here. Okay, so the signs change if you factor out a negative factor. So I'm just going to write if your factor is negative, signs of the terms change. Okay, so I'm going to put an arrow there to show which factor I'm talking about. So let's look at another example. And I'm going to start not showing you the expanded version before we do the factored version on the next slide, so you can start to see exactly what you're going to need to do. But just one more example, because this time we have a 3x multiplying an x. When you have a 3x multiplying an x, the x power changes to an x squared. 3x times 5 would be 15x. So when I look over here, now my letters have to be looked at as well. I've got an x squared and an x. That means I have something in common there. Now, because I don't have enough room at the top, I'm going to do it below. So what does 3 break into? 3 breaks down to 3 times 1. 15 breaks down to 3 times 5. Now, it could be 15 times 1, but I already know there's a 3 here, so I just went through all the things that multiply to 15 in my head, and I realized that 3 times 5 has a 3. So my greatest common factor for the numbers, the coefficients, is going to be 3. But if we look at the letters now, x squared means what? X squared means x times x. X is what two things multiply to x. So x times 1 are the two things that multiply to x. So what is my greatest common factor? For the letters, it's x and x. That means that I have to pull out a 3x from both of those terms. What are my leftovers? Well, my leftovers are the 1 and the x multiplying together from both of those things, okay? So 1 times x is 1x. And then what are my leftovers here? Well, I have 5 times 1. So 5 times 1 is just 5. And then another way of thinking of this, folks, which might be easier, is 3x squared is being divided by 3x, and our leftover is 1x. 15x is being divided by 3x, and our leftover is 5. So, and I'm going to start using that method more than any others, okay, which is the direct opposite of this method. So we multiply in for expanding, we divide out for factoring, okay? So let's continue here. So factoring means, once again, take things that are adding and subtracting and turn them into things that are multiplying. And this type of factoring is called common factoring. Common factoring means find something that's common to both or all 3 or all 4 terms. You can have multiple terms involved. And pull that thing out in front by dividing it out. So looking at these two terms here, we've got 4x squared plus 8. How quickly can you find the thing that divides out of 4x squared and 8 that is the greatest common factor? So the greatest common factor is 4 in this case, because 4 is 4 times 1. It could also be 2 times 2, right? But I'm also looking at the 8 right away. Now 8 could be 2 times 4. It could be 8 times 1, but now both of them contain a 4. So 4 is my greatest common factor. I look at my letters next. There's an x squared here, but there's no letters beside the 8. Therefore, there are no common factors with the letters. So what I do is I write the 4 out in front. I open a bracket, and I write the leftovers inside the bracket. Now, what are the leftovers? I have a 1 and an x squared. So that's 1x squared, which we're just going to write as x squared. And my leftovers for the 2, I don't have a letter. So for the 4, I mean, is just a 2. And I have now factored this expression. Now, you can always double check your answer by redistributing in your head. So 4 times x squared is 4x squared. 4 times 2 is 8. Now if we look at this one, 5x squared plus 10x. Can you see that both of these contain a 5? So without writing the factors above anymore, okay, we have 5 times 1, we have 5 times 2, So my greatest common factor is a 5. However, this time I do have letters involved. So how many x's do they have in common? Well, this one has 2 x's, but this one only has 1 x. So that means they only have 1 x in common. So my greatest common factor is 5x. So I'm going to pull that 5x out in front. I'm going to open a bracket. Now, why am I saying pull the 5x out in front? What I'm visualizing here is the 5x is jumping out of both of them, which is the reverse of the distributivity that would have brought it in the first place. So the arrows this time are going this way, and they combine together to give you the one thing that distributes in. Okay? So what's left over when I pull out the 5x? Well, what's 5x squared divided by 5x? 5 divided by 5 is 1. X squared divided by x is just x. If I divide 10x by 5x, well, 10 divided by 5 is 2. X divided by x is 1, but we don't write that 1 because it's a multiplication times 1. And then I just look at my signs. I didn't take out a negative value, so it's still going to be an addition inside the bracket. And you can distribute this. 5x times x is 5x squared. 5x times 2 is 10x. So let's do one more example, maybe a couple more examples. So what if I gave you something like that? Well, what two numbers do I have here? I have -3 and 9. What is my greatest common factor to -3 and 9? Well, both of them contain 3, but this is an example where we have a negative sign in front of the first coefficient. And as soon as you have a negative sign in front of the first coefficient, you actually want to take that negative sign out with the number. So our greatest common factor numerically is going to be -3. We also have letters that are in common. We have an x squared and an x. Both of them share 1 x in common because this one only has 1. So my greatest common factor is -3x. So I'm going to pull that -3x out in front. Now what are my leftovers going to be? My leftovers are going to be -3x squared divided by -3x. So -3 divided by -3 is 1. X squared divided by x is just x. And then here, I'm going to have 9 divided by -3, which gives -3. X divided by x is 1, which we don't write. So the sign here between the two terms changed because we pulled out a negative sign. In fact, the sign in front of this term changed as well, right? It was a negative in the first term, and now it's a positive in the bracket. That's because we pulled out the -3x. So what if I gave you something like this? The bigger your coefficients get, the scarier your common factoring becomes. Simply because you have to be very, very good at your times tables to be able to break down the coefficients into everything that multiplies and find the greatest common factor as fast as possible. Now, 24 is a nemesis of mine because of how many factors it has. 24 can be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So anything that's 24 or a 24 times 2, or which should be 48, any kind of combination like that, 24 has a lot of factors. All right, so you have to be able to list those factors very quickly, and then you have to look at the other thing, 36, and be able to break that down into things that multiply to 36. Well, I'm hoping you see that 36 is 6 times 6. Okay, and that's going to be the greatest common factor, or is it? Wait a second. 36 is also, and this is what I was talking about. We've got 1 and 36. 2 and 18. 3 and what gives 36? 3 and 12 gives 36. Well, look at here. That means 12 is the greatest common factor to both of those two numbers. Okay, so I almost missed it. And then we also have a greatest common factor for a letter, which would be just x in this case. My leftover is 24 divided by 12, which is 2. X squared divided by x, which is x. 36 divided by 12, which is 3. X divided by x, which is 1, which we don't write. And that is my factored form for that one. So be very, very careful with bigger numbers to make sure you consider all of the factors for both of those. Now, what would have happened had I thought it was 6? Okay, what would have happened? Or what happens if you pull out a too small of a factor? So let's reuse this same example and talk about what would have happened had I thought it was 6. Okay, so if I thought that 6 was the greatest common factor numerically, x is still a factor for the two letters. 6 times, or 24 divided by 6 is what? It's 4, and then I'd have an x left over, and then 36 divided by 6 is what? That's 6, and then my x is gone because x divided by x is 1. Well, factoring means pulling out numbers until you can't do so anymore, okay? So you want to be able to divide your numbers completely. Well, looking at 4 and 6, can you see how there's another factor there? I can divide both of those by 2. It's 2 times 2 and 2 times 3. So that 2 could be, once again, common factored. Now, if I bring the 2 out with the 6x, it multiplies that 6x. My leftover would be 2x plus 3, and 2 times 6 is 12, which gives me the same answer that I got above. It's a little bit longer because I missed the greatest common factor, which can happen. Okay, I almost made the mistake a couple of seconds ago, but sometimes I pick the wrong one by accident. I think it's the greatest common one, and then when I think I'm done, I look at my bracket and I say, am I done or not? In this case, I wasn't done because both of them are still divisible by 2. All right, so 2 is another factor. It comes out in front and joins the wrong greatest common factor that I thought I had. And that's going to be it for the lesson on common factoring. So have a great day, folks, and we'll see you in the next lesson.